All right, guys, on page 60 of your notebook, or page 60 of the digital textbook, I would write down or look at the note sheets of 2-1 for the greater than, less than or equal to, or greater than or equal to, so that we can look at those. Because again, it's referring back to these here. Yep. Here, number x is more than -3. So more than would be talking about what? Our greater than. So we're looking at 1 through 4. So more than deals with greater than. So we'd have x is greater than -3. And so we'd graph it. We would draw -3 on the line. And the circle would be opened or closed. And we would shade to the left or to the right. That's all we need to do on this here. Any questions on this here? Are there any other questions on how to do 1 through 4? Any questions on 1 through 4? Any one of those that you need to see done or worked?
Oh, I got all of. I know, but that's where I started to get.
So if there's no questions on, guys, focus up here. So if there's no questions on 1 through 4, are there any questions on 5 through 8? Check to see if the given value is a solution to the inequality. Any questions on any one of these here? So again, when we do these here, what we're doing is we're taking whatever value is told to us. So like number 7, so 1/4. So if I want to check it, what we're going to do is we're going to plug 1/4 into the equation for x. Now at this point here, we just need to simplify this. So 4 times 1/4 squared minus 15, we can plug this into the calculator. So it'd be 4 times 1/16 minus 15 is less than or equal to, it'd be 81. Well, this would just end up being 1/4 minus 15. We get this here. And again, so if we plugged it into the calculator, it'd be 14.75 negative. And yes, that is less than, so it does work. So if we're checking to see if a value does work, we're plugging it in for that variable or variables if there's more than one, and seeing does it make a true statement, because if it makes a true statement, then it does work for that value. Are there any questions on these 4 here? Are there any questions on these here that you need to see done or worked? Nine through 12. Any questions on 9 through 12? How we graph these or how we do these here? Are there any of these here that we need to see worked or done? Now, with most of these here, it's dealing with our sign. Now, number 10, the square root of 81 is 9. Open circle, since we're saying x is less than it, we're going to shade to the left. Now, number 411, and well, it's 4 over 21. The circle would be filled in because it is equal to, and then we would shade to the right because it's talking about it being greater than. Any other questions on this one here? Any questions on this here? If there are no other questions on 9 through 12, let's look at 13 through 24. Any questions on either one of these here, 13 or 14? Either one of these here that y'all want to look at, 13 or 14. Well, let's look at least 14, because what we're trying to do is get the value of x by itself. So we have 6x is less or greater than negative 36. Or negative 6x is greater than 36. Well, to get x by itself, we need to divide both sides by negative 6. Well, negative 6 divided by negative 6 will simplify. 36 divided by negative 6 is, and whenever we multiply or divide by a negative, we have to flip the sign. And when we flip the sign, it changes it from greater than to less than. And because it's not equal to, we don't fill the circle in. And then we shade to the left. And we get this here. (15) and 16 are very similar. We're just trying to solve for the value of x. So on number 15, we have x minus 27 equals 10. Well, to get the value of x by itself, we're going to add 27 to both sides. And when I add 27 to both sides, well, negative 27 plus 27 will cancel, leaving me x by itself. 10 plus 27 gives us 37. So we're left with x is less than or equal to 37, so the circle would be filled in, and we would shade to the left because it's less than. X is less than 37. And that's all we would need all we need to do for this one here. So are there any questions on 15 or 16? Any questions on either one of these that we did here? Okay, if there's no questions on these two, let's look at the next ones. Any questions on 17 or 18, how to solve either one of these here? Any questions on 17 or 18? I'm going to look at 18 because this has two steps. Well, the first thing we need to do is we need to get x by itself, and the easiest thing would be to subtract 3 from both sides, because 3 minus 3 would give me 0. So I have x over 2. 7 minus 3 would be 4. Because again, since we had something added to it, we would subtract it from both sides. Since 3 is being added to our x over 2, we would minus 3 from both sides, because 3 minus 3 would give us 0. And now we have x over 2 is less than or equal to 4. Well, x and 2 here are being what? Multiplied, divided, added, subtracted. They'd be divided, because they're dividing, they're over the top of each other. So to undo division, we would use multiplication. So we multiply both sides by 2, because the 2 and 2 would simplify. Because really, when we multiply by 2, I'd have 2x over 2. 2 divided by 2 would be 1, so I have x is less than or equal to, well, 4 times 2 is. Now, because it's equal, we would have a closed circle. We'd fill the circle in. Now, do we need to shade to the left or to the left? Now, it just worked out that the ones we've done so far have all been less than. So we'd shade to the left. It doesn't always have to be that way, but for these here, it's worked out to be less than. So any questions on 17 or 18? Any questions on 19 or 20? Either one of these here. Any question on how to do 19 or 20? Or one of those that you want to see worked? We can do 19. So the first thing we need to do is we need to get the variable by itself. And I want to do addition and subtraction first. So looking at this here, I have negative 6x minus 24. Well, I want to move the minus 24 first. And I can do that by adding 24 to both sides, because the opposite of subtraction is addition. So negative 24 plus 24, these two here would cancel and become 0, which leaves me with negative 6x. Well, 0 plus 24 is 24. Now, is x by itself? Well, no, it has what? The negative 6. So what do we need to do? We need to divide both sides by negative 6. Is negative 6 divided by negative 6 would give us a positive x. 24 divided by negative 6 would give us negative, and our sign would be greater than or equal to, because again, anytime we multiply or divide by a negative number with inequalities, the sign has to flip. Anytime we multiply or divide by a negative with inequalities, the sign has to flip. Now, because it's equal to, we will fill this in. Now, since it's saying x is greater than negative 4, we shade to the right. Any questions on this here? Any questions on number 19? If you multiply or divide by a negative, anytime you multiply or divide by a negative, you have to flip the sign. If you just multiply or divide by a positive number, it doesn't change. But when we multiply or divide by a negative, it changes. So if we looked at, like, say, number 20. So if I multiply through by 2, well, 2 times x is 2 times negative 3 is negative. So this one here required us to do the distributive property. We had to multiply through by 2. Because we had to do that first to be able to solve. Now the next thing I need to do is I need to get the 2x by itself. Since it's being subtracted, since we're subtracting 6 from it, we would need to add 6 to both sides. Because negative 6 plus 6 would cancel, leaving us with 2x is less than. Now at this point here, we can both sides by 2. Will 70 or 37 divide by 2 evenly? No. I can leave it as 37 over 2. That's perfectly fine. We could leave it as, we could simplify it to 18.5. That would work too. It doesn't matter how the form is, so we can leave it as 37 over 2. Now the circle would be open because it's not equal to, and then we would shade to the left. Any other questions on these two here? Let's look at 21. Well, the first thing we need to do on 21 is to distribute 2 across the left side. So 2 times 6w would be 12w. 2 times negative 1 is negative 2. It is less than or equal to, well, 3 times 7 is 21. 3 times 4w is plus 12w. Now, for most of these multi-step ones, we want to get the variables on the same side first. So what I can do here is I can subtract 12w from both sides. Well, 12w minus 12w is 0. Well, it works out to be 0 here also. So negative 2 is less than or equal to 21. Is this a true statement? So this here is all real solutions. So when it's all real solutions, we shade everything on the number line because all of it is true. So we don't really have to put any numbers in. We can just shade the whole line, and it shows that everything works because it's all real numbers. Now we can do the same thing on this other side and multiply both sides through by negative 4, which would give us, well, negative 3, or 3 times negative 4 is negative 12. Negative 4 times negative 1, well, a negative and negative make a positive. 12n. And to do the same thing, I would add 12 in to get n on the same side. Well, for this one here, they both cancel out again. And we get 4 is greater than 5.2. Well, that's not true, is it? 4 is not greater than 5.2. This here is no solution. No solutions. Now, for most of these here, most of the problems that we'll have, I don't normally like doing no solutions. But where some of the absolute value ones, I will put them in there because, again, it's really seeing the absolute value can't be less than a negative. It's kind of the big key points. Now, for something like this here where we're solving them, like these two here, I will put a all real solution, and that might show up, but I won't put a no solution for this type. Okay? For this type. Now, the absolute value might come up as no solution, but for these here, these multi-steps, these here, not the absolute value, these here are not going to come up as a no solution. Now, looking at 23 and 24, is there one of those that y'all want to look at? Y'all want to look at 23 or 24? Now, we look at this here. The first thing we need to do is we need to apply the distributive property. We need to multiply through. Well, negative 4 times x is going to be negative 4x. Negative 4 times positive 3 is going to be negative 12. We have to do it again over here. Negative 7 times x would be negative 7x. Negative 7 times 1 is negative 7. So again, the first thing we need to do is distribute. We need to distribute through. Now, once we finish distributing, we can combine like terms, these here, or these here. Because 2x minus 4x, well, 2 minus 4 is negative 2x minus 12. Now, negative 7 on this side doesn't have, negative 7x doesn't have any like terms. But 3 and negative 7 are like terms, yes? So 3 minus 7 would be negative 4. Any questions on anything we've done so far? Now, what we need to do next is we need to get the variables on the same side. And then everything else on the other. So I could add 2x to both sides, or we could add 7x to both sides. What do we want to do? We can add 2x. And when we add 2x to both sides, well, negative x, 2x plus 2x would cancel, leaving me with negative 12 on one side. And over here, negative 7 plus 2x would be negative 5x. Now we need to do it again because 5x is not by itself. I need to add 4 to both sides. Does that give me negative 5x? And I would have negative 8. I'm going to move it over here because I think y'all have a little bit more space than I do up there. Yes? So is x by itself? No. What do we need to do to get it by itself? By? Not just 5, but negative 5. Because we need the value of x to be positive. When we solve for the value of x, we need it to be positive. Now, negative 8 divided by negative 5 would be positive 8/5. But because we divided by a negative, we have to switch the sign. We have to switch the sign. Anytime we multiply or divide by a negative with the equalities, we have to switch the sign. So we get 8/5 is greater than or equal to x. So greater than or equal to. So it means the circle is closed. Now, would we shade to the left or to the right? To the left, because we're saying x is less than it. Because 8/5 is greater than or equal to x, or really x is less than or equal to 8/5. These are the same statement. X is the smaller value, so we have to shade to the left. Are there any questions on this here? This here? No, since they're on the same side of the equal sign or the inequality sign, we can combine them. We only do the opposite sign as if we're moving from something from the left to the right. Or we're moving across the equal sign or across an inequality. We only do the opposite is when I'm trying to move across this inequality sign. Because whenever we're trying to move across an inequality sign or an equal sign, then we have to do the opposite. When we're on the same side, we can just combine like terms. We can just combine them. Any other questions on 23 or 24? We good with these two here? Any questions on 25 or 26, how to write these? Do you have any questions on how to write these here? Y'all want to see how these are written? We're good with these here? We can do these on a test? So this here, when we look at 25, we have 2 points and it's shaded in the middle. Since it's shaded in the middle, it means x is going to be, or the variable is going to be in the middle. Now the 16 would be less than, or bigger than x. Yes, that's the biggest number. What's the smallest? So we kind of have this set up here. Now we do have the arrows going in this direction. Now is 16 equal to x? No. How do we know? Because it is open. Since it's open, it's not equal to. But how about 27? So we need the equals to. That's all we do for this here. Questions on this here? Now 26 is 2 different ones because I have one shading to the left and I have one shading to the right. So this is really our OR, compound inequality. So we're going to have 2 statements. One where x is greater and one where x is less than. So what is x greater than? 16 over 5 because it's shading to the right. And we would put greater than or equal to because at 16/5 the circle is closed, yes? So it would be equal to. Now x is less than -7/2, and we wouldn't put equal to because the circle is not closed, it's not filled in. Any questions on this here? Any questions on anything we've done so far? Any questions on 27 or 28? 27 or 28? Is there one of those that y'all want to look at, 27 or 28? Well, let's just look at 27. A number p is more than -6. So more than. More than is greater than, and it's not equal to, so we have more than -6. And is at most 2. Well, is at most refers to less than or equal to. And again, as I said at the start when we looked at the first few, I would copy down the words for each one of these symbols in the review sheet. So I would look at chapter 1 or 2.1 on the virtual textbook on Big Idea Math, or look at your notes for 2.1 to have these down. You can write these down on the review sheet, and that would be helpful. Now, because this is an and, it's talking about what's in common between these two here. So -6 and 2. And it's talking about what's in the middle. Now, -6 is just greater than it, so would we fill the circle in at -6? P is less than or equal to 2, so here we would fill it in. And that's all we need to do for 27. Now, 28 is an OR statement. A number n is less than -7 or greater than 12. N is less than -7. Or n is greater than 12. So this one here is a little bit easier. We're not having to really look to see less than or equal to, just greater than or less than. Now with these here, we kind of fill in what's there. So n is less than -7. So at -7, we're shading to the left. Here, n is greater than 12. So we would shade to the right. And that's all we need to do here. So we're really reading it and just putting it down on the graph. So are there any questions on these two here? 27 or 28? We good with these two here? So if we're good with those there, we can move on to these here. Now these compound inequalities, so we'll do one of each. We'll do these two here. When we have a compound inequality, we have two inequality signs and a variable in the middle. We solve out. We try to get the variable by itself. So the first thing we need to do is, well, 2x plus 6. I need to minus 6 from all three sides. Because again, we're trying to get the variable by itself, and anything we do to one side or to get x by itself, we do to all three. We do it to the middle, to the left, and to the right. Because in the middle, 6 minus 6 would be 0, leaving us with just 2x. -42 minus 6 would be -48, and we could have plugged that in a calculator to make sure this works. 12 minus 6 would be 6. So the first thing we did was subtract 6 so that we can get closer to having x by itself, and we're almost there. Now the only thing we have left is the 2. And to get rid of the 2, we're going to divide all three sides by 2. Because 2 divided by 2 would give us just x. 6 divided by 2 would be 3. And -48 divided by 2 would be -24. And what we need to do to finish this off is we need to graph it. Now we're going to shade in the middle because x is in the middle. Whenever the variable is in the middle, we would shade in the middle. But now we need to figure out which circle's open, which circle's closed, or if they're both open or both closed. Well, there's only one equal sign, and that's with the, so we would shade in the -24, and we would leave the other one open. And that's all we would need to do for this here. Any questions on this here? Yes. Yes. Now we're going to look at the other one. Now this one here is an OR statement. So what we would do is we would solve each one individually. So we can deal with the 6x minus 7 is less than -2 first. We're going to solve it for x. And then once we finish solving it for x, we'll solve the other one. So what we need to do first is we need to get the value of x by itself. So I would add 7 to both sides. Because when I add 7 to both sides, well, -7 plus 7 would give me 0. So I'd have 6x is less than. -2 plus 7 would give me 5. Now at this point here, to get the value of x by itself, I would divide both sides by 6. And when I divide both sides by 6, I get x is less than 5, 6. So we're halfway done. I've solved for one of them. And once I finish solving for one of them, we would solve for the other one. So the first thing I would do is I would subtract 3 from both sides, because again, we want to get x by itself. And 3 minus 3 on the left side of this would give me 0. So I'd have 2x is greater than. 5 minus 3 is 2. At this point here, we can divide both sides by 2 because, again, we want to get x by itself. And I would have x is greater than 1. Now, our first statement here is x is less than 5, 6. So at 5, 6, it would be open, and we would shade to the left. Then at 1, it would be open because, again, neither one of these is equal. And we would shade to the right because it's saying x is greater than 1. Any questions on either one of these here? Any questions on either one of these here, these compound inequalities? What we did to solve either one of these here? Okay, if we're good with those there, we'll move on here to these absolute values. Now, absolute values. With an absolute value, if we have greater than or equal to or greater than, it's an or statement. If dealing with absolute values and we have less than or equal to, it's an and statement. And it's going to be key to remember this because this will help us with solving. This is crucial in solving these here. Now, because this here we have the absolute value of x plus 2 is greater than or equal to 3, we are dealing with an or. It's an or statement. There will be 2 statements with this here. We have an or statement because one of them is going to be x plus 2 is greater than or equal to 3, and the other is going to be that x plus 2 is less than or equal to negative 3. We have 2 statements here. We're always going to have 2 statements here. So what we're going to do here is we're going to subtract 2 from both sides to solve for the value of x because we need to solve for both of these here. And these 2 2's will cancel, leaving us with x is greater than or equal to 1. We need to do the same thing to the other side. We're going to subtract 2 from both sides because negative 2 and negative 2 cancel, leaving me with x is less than or equal to, well, negative 3 minus 2 is negative 5. None of the lines down there, but we can rewrite it. Negative 5 and 1. Now, both of these circles are going to be filled in because it is equal to on both of them. Now, here it's saying x is greater than or equal to 1, so at 1 we'd be shading to the right. Now, the other one is saying x is less than or equal to negative 5, so at this point here we would be shading to the left. And that's all we would need to do for this one here. Are there any questions on this? Any question on anything we've done so far? Now, looking at 36, the absolute values are by themselves, yes? The absolute value bars are by themselves. There's nothing being added outside, nothing being multiplied outside, yes? And what do we know about absolute values? They will always be greater than or equal to 0, yes? So this here will always be greater than or equal to a negative number, yes? So this here is all real numbers. It's always going to work out that the absolute values of anything, the absolute value of anything will always be greater than 0, greater than or equal to 0. So it's always going to be greater than or equal to negative 3. It'll work out every single time. Let's look at 39. So this here is less than. Well, we have a negative number, yes, but do we still have something added or subtracted or multiplied outside the absolute values? Yes? So before we can say anything, we need to get the absolute values by themselves. So we're going to divide both sides by 468 over 231. And when we do that, I get negative 784 over 9x plus 2 is less than or equal to negative 231 over 234. So is this thing still less than or equal to a negative number? Will the absolute values ever be less than a negative number? No. So this one here is now one of these might show up on the test, the absolute value. If an absolute value is less than or equal to a negative number and there's nothing being added or subtracted outside of the parentheses, then it would be a no solution. But we've got to get the absolute value bars by themselves before we can say that that is true. Before we can say that is true. So looking at the rest of the absolute values, are there any of those that you want to look at and see, or see how they are solved? Are there any of the other absolute values that we want to look at? So we good with all of these here? Yes? Okay, tomorrow is your test. I would definitely make sure that you've done some of these here, looked over these here. And especially with your chapter 2.1 notes, I would write down the greater than or equal to, how they are shown in word form. Because having all of that there will help you on the test.